موعدنا الآن مع مقهى العلوم حول الحلول المبتكرة للطاقة المائية المتكاملة بحضور الدكتورة منى جمال الدين، عميدة كلية هندسة الطاقة والبيئة والكيماويات والبتروكيماويات بالجامعة المصرية اليابانية، والدكتورة علا جمعة، أستاذة التقنية الحيوية الدقيقة في هيئة الطاقة الذرية بمصر، ودكتور كومار باتشيجولا، محاضر أول في أنظمة الطاقة منخفضة الكربون ومركز أنظمة ومعاد الطاقة الحرارية جامعة كرانفيلد. سيناقش هذا المقهى العلمي كيف يمكن الحلول المبتكرة للطاقة المائية المتكاملة أن تحسن حياة الإنسان وتقلل الطلب على المياه والطاقة من خلال فترات النقص. هذه الجلسة مقدمة من المجلس الثقافي البريطاني. المايك مع حضرتكم.
Assalamu alaikum. Good evening, ladies and gentlemen. It's our pleasure to present the virtual science cafe that will discuss innovative water energy integrated solutions. First, I would like to thank the Arab Science Week team for giving us this opportunity. This session is presented by the British Council. So I'd like to thank Ms. Elizabeth White, Ms. Shaima Al-Banna, and I also like to thank Ms. Nisma Ashraf and Ms. Ferry Shafi for their extensive efforts and thorough preparation for this session. The Science Cafe is one of many activities of the British Council. It aims to promote scientific discussions and to break the barriers between scientists and public, and to discuss important topics in a simple way. And our topic today focuses on finding new integrated solutions to overcome water scarcity in Egypt and the Arab world through desalination. According to the United Nations, the number of people who live under limited access to water are around 2 billion people. It's expected to increase to reach from 3.5 to 4.4 billion by the year 2050. The future of water situation in Egypt looks even more gloomy, with the construction of the Ethiopian dam. Therefore, it's crucial to look for new water resources. In order to obtain clean water, we need energy, and this adds up to the cost and presents a new challenge to the environment. So to reach water security, we should pursue innovative technologies that will provide potable water using clean sources of energy without compromising the environment. Both sustainable water management and renewable energy are addressed in the Sustainable Development Goals. They're highlighted in the Egypt 2030 strategy and addressed as key topics in all national and international scientific funding calls. They are also among the priority areas in Newton Musharraf calls. So tonight, we will discuss one of Newton Musharraf Institution Links projects entitled Low-Grade Heat Recovery for Absorption, Chiller, and Desalination from Concentrated Solar-Powered Steam Power Plants in Egypt, a collaboration between Cranfield University in UK and Egypt-Japan University for Science and Technology in Egypt. Without further ado, I would like to introduce our speakers for tonight. Dr. Kumar Pachigola, the UK PI, Senior Lecturer in Low Carbon Energy Systems at Cranfield University in UK. Dr. Pachigola has a very strong track record in research with 49 publications and H-index of 16. He also works with universities in UK and have international collaborations with other 7 countries. His research focuses on renewable energy and energy storage. Dr. Pachigola will talk about water production via desalination and how it can contribute to solving water problems in the Arab region. We're also honored to have the Egyptian PI, Professor Munna Jamaluddin Ibrahim, Dean of Energy Resources, Environment, Chemical, and Petrochemical Engineering School at Egypt-Japan University of Science and Technology, Aegis. Professor Munna has published excellent research over 25 years covering most significant environmental fields. She has contributed to both research and education and has led multiple committees. She's a high caliber expert and consultant. Professor Munna will talk about the joint project. But before we start, some house rules, please mute yourselves. If there are any questions, write them in the chat box on the right side or raise your hand. We'll open the floor for Q&As after speakers finish their presentations. Okay, presenters will stick to 10-minute slots. Thank you. So now Dr. Kumar may start. Kindly share your screen.
Okay, thank you all for introduction. I'll echo Ola to thank Arab Science Week. Can you hear?
Yes, there's a little bit of echo, but it's good. Go ahead.
Okay, I can't switch on my video. That's something stopped the host.
Okay.
It's coming up saying that I can't start my video because the host has stopped it.
Yes, because you have the presentation on screen right now.
Okay, start my video. Okay, that's fine. Okay.
Yes.
Yes, you can now.
Okay, that's great. Thank you. Thanks for Arab Science Week and the British Council for giving this topic, Arab Science Week. Now, next 10 minutes, I'm going to talk about general aspects of water production via desalination approaches. Next slide, please. Before talking about water production via desalination, a reasonable status for water production through desalination is an important aspect. Okay, as probably most of us will know that our population is started growing up. To give a figure, the world's population by 2050 is going to be approximately 10 billion. Out of those 10 billion, how many people will be in the Arab region, which is currently we are talking about around 422 million population. What it will be by 2050, based on the current statistics, it is showing up that another 20 million people will increase it. And at the same time, these Arab regions is rich in solar energy. And issue based on the water. So in order to give the water supply for these communities, what sort of things we are at the moment. Before giving information, I need to know what shortage of water issues. Based on a general United Nations, it's clearly showing that water scarcity affects more than 40% of global population, which is, we talk about 10 billion, within Arab, around approximately 420 million people. Out of this, current statistics shows that approximately 1 out of 3 people don't have access to safe drinking water. And in the same time, because of these safe drinking water issues, approximately a child every 2 minutes dies because of lack in drinking water. Where is this water comes from? Everybody knows that most of this water is available in ocean, which is approximately more than 90% is available in ocean. That is saturated with the salts. What is water available? Particularly to the Arab region, on the left-hand side, figures to demonstrate, top left-hand side is approximately like a 2000 to 2010 figure, where water problems occurring. It is clearly demonstrated as a red, green, yellow, like a traffic light signals. If that is projected and predicted for 2020 and 30, what is the situation? As you can see that green is changed into orange, orange might be into red. Those things, it is water scarcity is increasing, and it is creating the problems onto the earth as well as agricultural purposes. This is a declining this water availability per that. On this aspect, can we do something better for the world population, which is, we talk about 10 billion people by 2050? What we can do that to provide their necessary energy needs? In order to do that, what is that basic needs? Do we know that per person per year, how much of energy and water is needed? Based on estimates, energy needed is approximately 5 megawatt hour. It is a huge quantity, along with the water need per person per year is around 350 meter cube. As we can see that global population is increasing, and 1 out of 3 people don't have water access, demonstrating that 2 times of this figure need to be produced and supplied to the global population. How we can do that to provide this water needs for global population? either by doing some improving the efficiency so that the water wastage will be reduced, or recycling the wastewater, treat them, or reducing the energy costs so that that energy can be used for water. You can manage it for providing these basic needs. At the same time, desalination is the solution currently significant, which has some few drawbacks. It is a growing focus, and global desalination capacity is doubling by 2030. So why can't we solve the world's crisis with available seawater by simply doing a simple general concept of filtering the fresh water from these saturated salts via desalination? Traditionally, there are two methods, reverse osmosis and thermal desalination. Thermal desalination is tend to be like a old traditional method, boiling water, capture the vapor and condense it, like a kind of doing it everyday life at home, boiling the kettle, and on the top it is water is condensed. What are the other methods, desalination technologies available? It's either thermal and membrane. There are a few options highlighted here. If it is reverse osmosis through membrane technology, using a pressure force to apply to separate the water from saturated salts with the water. Dialysis is applying electricity to convert the ions, separating those ions through the electrodialysis process, and other way is reversal process. In thermal, it is simply heating up using multi-stage flash distillation. It is somewhat similar to like traditional distillation process for separating the salts with the liquid, and more recent one is vapor compression distillation. There are n number of desalination technologies available. How it is performing, what is that comes with these desalination technologies. To start with, the first column is talk about desalination technologies in acronyms: multi-stage flash distillation, multi-effect, thermal vapor compression, those things as I mentioned in the earlier slide. What type of water can be used? People talk about using seawater, blackish water, or somewhat of wastewater treatment as well. How much energy consumption per meter cube of water production? How much of thermal energy is needed? What is the source of operational temperatures for the respect to these technologies? This slide to give you a global distribution of desalination plants, where you can see that most of these desalination plants is pretty much occupied in the Arab regions with different capacities. As these dots showing up, that the bigger the dot, it is a larger production per day, meter cube per day. And it depends on the color, which is talking about what type of feed water they are using it, either seawater or industrial wastewater or blackish water and those things. It is globally spread more or less as an Arab region. Next slide, please. So pretty much people talk about this desalination and applied it. What are the main concerns? There are reasonable concerns still do exist with desalination process. How much of energy is required to treat this ocean water in order to provide this clean water for the needs? Is there any sustainable route? Yes, there will be a sustainable routes. However, this treating this ocean water is highly energy intensive process compared to treating that wastewater. Even though you treat that wastewater, that won't be sufficient to supply the water need for the rise in global population. What about how much it costs? What would be wastewater treatment? Based on reasonable economic studies, people talk about twice it cost compared to treating the wastewater. But at the same time, even though it is costly and highly energy intensive, you need to produce a clean water using the seawater. What are the impacts? this is one of the interesting aspects. Globally, people are researching it. One thing is, can you use fossil energy to do this saturated water? Probably not. As we talk about, that leads to carbon dioxide emitting into the atmosphere. How you will reduce that carbon dioxide emission? Is there any alternative routes? So for this one, desalination is not only the solution for water scarcity, it is one of the options to narrow the gap between supply and demand issue. Pretty much it is talking about using fossil fuels. What are the routes we have? Concentrating on renewable desalination as an example is showing up. The bottom two is a part of Cranfield activities producing desalination like a household concepts using Fresnel lens. Go to our global applications. People are applying through solar stills and sugar water is passed through to produce the clean water. With that, I will stop my presentation with my colleague to talk about the current existing project we are doing.
Okay. Thank you, Dr. Kumar. Thank you for shedding light on the water problem and how it's important to find solutions to overcome water scarcity and discussing the pros and cons of desalination, especially for the Arab world. Thank you. We now give the mic to Professor Mona Gamal-Eddin to talk about the Joint Institutional Links project. Dr. Mona. Dr. Mona?
Yes, I am with you.
Okay, yeah, you may start.
Yeah.
Thank you.
But it seemed that the host has stopped the video for me.
You can try now, Doctor?
Yeah, try again. Yes, it's okay. Go ahead.
Okay, okay.
Thank you.
Thank you. Okay, first of all, it's my pleasure to be with you today. And I want to thank Arab Science Week and the British Council for this opportunity. Just a few words in Arabic, Dr. Kumar, to welcome our guests. السلام عليكم ورحمة الله وبركاته. أنا سعيدة أن أنا مع حضراتكم النهاردة في الأسبوع العربي للعلوم، وبتمنى لحضراتكم عام هجري سعيد بإذن الله. Okay, next slide, please. So this is just overview about our collaboration and our running project between Egypt Japan University for Science and Technology and Cranfield University. The PI is Dr. Kumar. The project submitted July 17, accepted July 18, contracted November 18, and activated January 19. For its duration is 2 years. Next, please. Okay, the project summary. This collaboration brings together solar desalination and environmental expertise and solar absorption cooling expertise from Cranfield jointly with, for this project. Energy and water sector in Egypt are currently facing a demand supply challenges, with Egypt's growing population led to a significant rise in the demands in agriculture, residential, and industrial sectors. In addition, there is an increased use of the generated power for driving conventional cooling systems. This affects not only the human lives, but it has a detrimental impact of local communities, social, environmental, health, and economies. Next, please. Egypt is one of the richest solar intensity regions to generate thermal electrical engines, and use of low-grade heat to run desalination and absorption units can offer a good opportunity to provide both clean energy and fresh water. This project is serving as an example of how innovative water energy integrated solutions can improve human life and reduce the water energy demand during shortage periods. Technically, this project introduced a tri-generation of first electricity, second water, and space cooling across all the sectors. Next, please. The project fulfilled the aim of Sustainable Development Goals 2030, especially for the following goals. Goal 3, good health and well-being, clean water and sanitation. Goal number 6. Goal 7, affordable and clean energy. Goal 11, sustainable cities and communities. Goal 13, climate action. And Goal 17, of course, partnership. Next, please. Next, please. Yes, this is the previous one, please. Yes. This is our system to simplify the idea of our innovative system. Here in the left side, the solar thermal system. In this first step of our process, the solar irradiation is gathered by a collector, and thermal oil is used as a thermal transmitting medium to generate the steam necessary for the Rankine cycle. The Rankine cycle, it is the ordinary cycle to produce the low-grade steam, or the excess of the steam. We use it for producing fresh water and cooling. For the fresh water, it is produced using the multiple effect desalination. Although multiple effect desalination is a mature technology, it cannot currently compete economically with the conventional RO, reverse osmosis, that needs less energy demand than multiple effect desalination. Through our project, as we use solar energy, we will produce the fresh water by multiple effect desalination and reduce the cost of the process. The third and the final output of the project is the cooling. The market available air conditioning systems, such as mechanical vapor compression technologies, need high electrical power and suitable refrigerants for their operation. Both requirements have high negative impact and contribute to global warming, climate change. The use of absorption cooling system driven by low-grade heat or solar thermal energy will reduce these negative impacts. Next, please. So the project technical objective to increase knowledge and develop the state-of-the-art on integration of electricity generation and absorption chiller and desalination unit, conduct a technical optimization assessment of these units to integrate the best sustainable and efficient technology. Second, design, fabricate, and commission a pilot test unit to verify the integration, demo training system for students and engineers. Third, analyze different scenarios and configurations of the tri-generation system and allocate stressed small communities in Egypt to provide energy water cooling requirements. Fourth, check safety of the fresh water product and its suitability for residential sector use. Next, please. Fifth, reduce water consumption for cleaning solar mirrors by demonstrating a novel dust barrier technology. And last point, to develop partnership for tri-generation system to different stakeholders for commercialization in a large scale for job creations and investment opportunities. Next, please. The project deliverables optimum tri-generation configuration in which the absorption and desalination units will be integrated with a concentrated solar power plant with an aim to effectively utilize the low-grade heat and increase the overall system sustainable efficiency. Second, master computer models for a techno-economic study, design and performance analysis for the proposed configuration. Third, environmental impact assessment of the tri-generation system, expected less impact on environment compared with conventional fossil fuel-based power generating system with significantly reduced greenhouse gas emissions. And by the way, I'm responsible for, in this project for the management of the whole project and the environmental impact assessment study and the water quality produced. And my colleagues responsible for the electrical and mechanical parts of the project. Fourth, developable working prototype of an optimum demo tri-generation pilot test unit of 10 kilowatt electricity, 1 cubic meter per day water, and 10 kilowatt cooling load. Demonstration of an effective dust barrier at the site of an existing SCP plant, thus reducing water consumption for cleaning. Next, dissemination and knowledge exchange through publication of peer-reviewed journals. And we already held a conference and workshop last year for the dissemination of the project. Last but not least, sustainability of the project. Next, please. The goal of this collaboration is to develop solar thermal energy and waste heat recovery for driving absorption and desalination units from solar-based thermal power plants. It will also be important to transfer the developed approach to other energy sectors, in particular for steam power and desalination plants, and expand to other areas in the world with energy crisis. Beyond the other regions, where potable drinking water is not practical through conventional methods, CRAFID and EJAS teams are planning to continue collaboration after the end of this project through apply for further joint funding from Newton Fund programs and other international focused sources, joint publications, seminars, training courses, and participate in regional and international conferences, supporting researchers to carry out PhD research in solar absorption, cooling, and desalination technology and sustainable cities. The team will continue collaborating with the industrial partners to develop the technology further for various applications. Thank you.
Thank you, Professor Mona, for this presentation. Thank you for sharing the idea and the objectives of your joint project. We can now see how integrated systems are the answer to water problems in Egypt and in the Arab world. We now have time for Q&As. So let us start by comparing how economical it is to use concentrated solar power system if we compare it to solar panels. Is there a difference? Dr. Kumar?
Okay, so your question is producing the water using solar panel or concentrated solar power. Yes. Okay, that is majorly required based on the amount of thermal energy you need to produce the water. More or less, the current solar PV system, thermal system, is capable of producing the temperatures up to say 60-70 degrees. That 60-70 degrees is not sufficient to drive this desalination process or the absorption chillers to provide the cooling load or some. However, if you concentrate it, the temperature coming out from these thermal systems will be slightly higher than water vaporization, which is, everyone knows that water boils at around 100 degrees. So even the seawater, you need to boil it more than 100 degrees so that the water, clean water will evaporate. So concentrated plants will perform effectively and produce more water in a short space available. But if it is a domestic applications, people talk about utilizing these traditional solar panels, means PV panels, with a thermal form using an evacuated tube.
Okay, thank you. We have another question. Dr. Mona, you mentioned in your slide that beyond the scope of the project, this system can be used in arid regions.
Yeah.
Wouldn't there be a problem of dust in, is it economical, would be efficient in remote arid areas?
Yes, for the task, as I mentioned, it is one of our objective, but up till now, we are, according to the Gantt chart of the project, now we are offering for the installation of the unit. We selected already the land, and unfortunately, according to COVID-19, we delayed. So we dropped from the duration of the project 3 months.
Okay.
So now we are offering for the installation of the unit. Then this is one of the important parts under study and one of the developers and outputs of the project.
Okay, that's great. Okay, thank you. There's another question about desalination. So Dr. Kumar, you mentioned that there's a problem with concentrated brine, and would it be placed back into the sea after use? Of course, it has so many environmental problems with the high salt concentration. Is there any, in your future work, is there any ideas or prospects about making use of the concentrated brine, or just what can be done instead of throwing it back into the sea?
Okay, that's a very good point. It's ongoing research, not currently on this UK Egypt project. We are doing on some other project. There are multiple options available to treat that waste concentrated brine coming out from this desalination process. Either you crystallize it, separate the salts out, and utilize that salts and make it use. People talk about at the moment using that salts, recover some nitrates and sodium and magnesium ions, and use that one for producing molten salts, and use that molten salts as a heat transfer fluid. At the same time, people investigating using membranes or wind assisted evaporation to improve the water evaporation quickly, so that the salts will be separated rather than feeding it into the sea. This is majorly talking about zero discharge solutions. So currently there is no solutions I'm aware of existing to treat these waste brine solutions, rather than sending it back into the sea. However, sending it back into the sea, it will have an impact onto the local marine life, because you are sending it back double the concentration approximately into the sea. So the marine life will be affected.
Did you think about maybe mixing it up or diluting it a little bit and then using it as a media to grow some microorganisms that are halotolerant, or they can tolerate salt?
That's a good point. Yeah, people do talk about treating, using that with the biological species to make it into biofuels or so. However, they got some implications there as well. All the sorts available there may not be suitable for this biological material to grow. First, you need to separate some of those salts out before doing this biological development. Otherwise, there will be a issue with the handling, means biological material might die. I'm not expert on the biological, but that is what some of the researchers do talk about.
Yes, yes, because some of the microorganisms, they produce biological material that of economical importance. So And I think some of the teams around the world, they work with the concentrated brine to produce something else. So I think it would add to your sustainability plan to put a biological, the dimension to the work. Yeah.
Yeah, you are correct. Absolutely. Yeah. At the moment, as I heard that we are doing something, means not us, in Oman, they are developing biological material to treat these produced water from this oil production and make them into biofuels. So this is very, very early stages at the moment.
Okay, that's great. And what are your plans after this project? Are you thinking of commercialization or upscale, or do you plan to do more research and development work on this? So, do you think of like the prototype? You mentioned the prototype in your, Dr. Mona mentioned the prototype in the presentation. So what would be the next step?
If you ask me as a UK point of view, and Mona might suggest something else as well, our view is to take, because we developed as a proof of concept and build this physical unit at Egypt, the next step is to take it forward and apply it to the communities so that we will see how user interacting with that unit, how that is performing, compared to specialized engineer operating at known place is different to general public operating the unit, and you need to make the interface ready. With that, we can develop more sophisticated, robust system with well-defined operational manual.
Okay. Okay, there's another question. Thanks for the presentation. Could we join desalination with salt production to deal with the concentrated flux? I think we already answered this question. Okay. Again, another question about the dust. We already mentioned that. So if we generally compare for energy produced by the concentrated solar power system, if we compare the energy produced to treating the water for the desalination, how do you compare to fossil fuel-based power in terms of price?
Okay, very good, interesting point. Here, you need to think about a little bit differently. You can't compare, means there is still, we can do that. Fossil fuel is, yes, it is available because that produces electricity and use that electricity to run the reverse osmosis. However, this renewable route is the free energy. Even though it is expensive, you need to think about it is a free energy and it is not emitting carbon dioxide into atmosphere. You got an additional benefit. And so that way you need to think about the benefits, it is comparing it. But however, once the process is improved, it can be comparable to reverse osmosis or some traditional fossil routes.
Okay, so it would be expensive, but
it
would be sustainable. Yeah, but sustainable, right? The clean energy.
Yeah, expensive, but it is in a sustainable route we are producing the clean water.
Okay, okay, thank you. And Dr. Mona, what about the climate change? Would it impact such a system? We're now experiencing in Egypt extreme hot weather and then extreme cold weather during the winter. So would that affect by any means the efficiency of the concentrated solar power system?
Yeah, as I mentioned, the unit, it is a tri-generation system for electricity, fresh water, and cooling. And for cooling, we are offering this absorption cooling system, which will use the driven low-grade heat from solar instead of the conventional mechanical vapor compression technologies that which use huge amount of electricity, and a refrigerant, as you know, has a high negative impact on environment and climate change, global warming climate change. So through this project and this innovative idea and unit, we are offering to use the solar irradiation, solar energy that Egypt and the whole Arab area has good solar irradiation. So it is sustainable tri-generation system using solar energy. Of course, will be reduce the cost of the multi-effect desalination unit. As I mentioned, comparing with the RO, it is the deficiency in multi-effect desalination, the economical point of view. So through using the solar energy, this technology will compete, will reverse osmosis.
Oh, okay. Yeah, and reverse osmosis also has its problems with the membrane and the biofouling and all that. Yes,
yes,
so,
yes, right, you are.
Yeah,
yes.
Okay.
So we are hoping, Yani, the output of the project is up till now is promising.
Okay,
for
great.
A practical application in many areas, especially in the North Coast, in Alexandria and Gordaga. One of our partners in Egypt is Ministry of Housing.
Okay,
as you know, Ministry of Housing is responsible for freshwater production, and they are happy of this idea and waiting for the output of the project to enlarge the scale and to apply in many areas in Egypt and Arab region, inshallah.
Okay. And how big is the prototype? I mean, is it something that it would be installed or fabricated and installed inside the university, or do you have like a special area or land to? Is it a big prototype?
No, it will be installed inside the university.
Okay.
In open air, but we'll cover part of it. Of course, the part of the solar energy will be open, and the other part will be covered in the university, aiming to be a educational and research unit for the students, for the public, and for the visitors, of course.
Okay. That's
we already selected the site, and it took time to select the optimum site for the unit. Just selected the site last month.
Wow. Okay, that's really great. Excellent. Okay. So we don't have more questions.
Dr. Ola, I'm sorry,
Yes.
just making sure that you have been through the questions in the Q&A chat also.
Yes, I can't find any more questions.
Okay,
do you have
good.
any? Yeah. Do you have any more questions?
I'm just making sure because some people asked it on the chat box, the normal chat box, and we have other 3 questions on the Q&A chat box. So just making sure that you have covered them all.
No, the Q&A. Okay. So another question is, any environmental assessment has been done to compare the environmental impacts of RO and MED coupled to solar energy?
Our environmental impact assessment will be done for our unit.
Okay. Okay, we have another question from Hood. Excellent project, thank you for sharing. Any results from implementation phase, again, i.e. RO versus thermal performance?
Okay, RO versus thermal performance. This is in particularly related to this project. We are doing the thermal performance coming out from this unit. But in terms of reverse osmosis, we are using open literature data because this project is not talking about reverse osmosis. However, we should not forget the vision for this project is using the waste energy coming from any steam power plants. Otherwise, that waste energy is going into the atmosphere. But however, in a reverse osmosis, it is not like that. You use a fossil fuel to burn it and produce electricity and use that electricity to drive the reverse osmosis process. In this case, any waste plant, it means any plant, if they are dumping waste energy into the atmosphere via traditional cooling towers, we are stopping not to do that, using that waste energy to drive these absorption chillers and desalination unit to produce the clean water and cooling load required for that local communities.
Okay, and by energy waste, you mean the emissions from burning the fossil fuels, right?
Yeah, burning the fossil fuels. If you see that power plants, you see a lot of water is evaporated through the cooling towers.
Yes.
That means that waste energy, that means exhaust from that turbine is dumping into the atmosphere. Okay. Rather than dumping that waste energy into the atmosphere, we are using that waste energy to drive these units to produce the clean water and cooling load.
Okay. And we have one last question. If the trigeneration becomes technically proven, do you see it applicable for treating oil and gas produced water?
Oh, that's a very interesting question. That is what, as I mentioned, it is people in Oman is talking about. I'm in discussions with the company. They have a lots of produced water. Can we use that produced water to make them into clean water? However, there is an interesting challenge that produced water tend to have a double the concentration as a seawater, normal traditional seawater. So treating that double the concentration is going to be a bit challenging. Yes, the technology can be used to apply it for treating that produced water as well.
Okay, thank you. We have two comments in the discussion section. Okay, so I'll try to translate this. What are the sources that can make me learn more about this field? And what are the day-to-day applications?
Set of applications?
Yeah, day-to-day applications. What the تطبيقات في الحياة اليومية. Okay, let's stick to the first part. What are the sources that can make learn more about or get deeper into this field of study? So what do they need to study in order to work in this field?
In this field?
Mm-hmm.
Yeah, they need to study energy resources, mechanical background engineering.
Okay.
And it needs a team, in fact, يعني not one person.
Okay.
But يعني mechanical engineering background, chemical engineering background, if environmentalists also. That's all.
Okay. And last one in the discussion section, how can we apply the rules of quantum physics on biology in terms of different immediate temperatures?
That's an interesting. I don't know how that's a quantum physics, a quantum theory can be linked to desalination aspects. That's a bit challenging.
I think this question was from the previous session because the chat box was
Really?
related to the previous session. I think this was maybe part of the previous session question.
No,
that's great in that case.
That's
I thought that how the quantum physics can be linked here.
Yes, the discussion. Okay. Oh, okay. Yeah.
That's logic.
Okay. So I don't think there are more questions. Nisma, would you like to ask anything?
No, I don't think there are more questions. So if you can please wrap up, Dr. Ola.
Okay. So Professor Mona and Dr. Kumar Prachivola, on behalf of the attendees, we like to thank you so much for taking the time to be with us today and sharing some important information about your joint project. For all the attendees, we'd like to thank you for your participation and for raising some really important questions that enriched the discussion. We hope that through excellent research that we reach water security one day in Egypt and in the Arab world. And thank you so much. Thank you.
No problem. Thank you.
Thank you for you, Dr. Ola, for coordinating the session. Thank you for all attendees.
Okay.
Yeah.
Thank you.
Thank you. Yeah.
Okay. Bye.
Okay.
Bye.
Thank you all so much for your contribution today with us.
Thank you. Bye.
Thank you. Bye.
Bye.
نشكركم على هذه الجلسة الممتعة والهامة، والآن قد نكون انتهينا من فعاليات اليوم الخامس من أسبوع العلوم العربي. شكرا لكل متابعي أسبوع العلوم من جميع أنحاء الوطن العربي. انتظرونا غدا للمزيد من المحاضرات العامة والجلسات النقاشية والبرامج العلمية الترفيهية، بالإضافة إلى المسابقات التفاعلية. ويمكنكم الاطلاع على جدول فعاليات اليوم السادس من خلال صفحة فيسبوك أو انستجرام أو تويتر أو لينكد إن. كما يمكنكم متابعة الفيديوهات الخاصة بالأسبوع على قناتنا على اليوتيوب.